Here's a simple substitution cipher, which basically just means you reassign all the letters to the normal alphabet. Every letter maps to one other letter, and then you create your ciphertext from that. This one is the most basic because you just personally randomly assign it. The hard part is then if you want to have someone else decode it, either they have to do a lot of trial and error, or you have to actually send them the key with it. So if we tried, this is a test, then it comes out to be this. One little thing you notice is you can start it out by adding a word that doesn't have any repeating letters. And if it does have repeating letters, just omit the repetitious letters. And then you can fill out the rest of the alphabet either in alphabetical order of the remaining letters or however you want to. I happen to put Findog as my word, and then I just put in the rest of the alphabet in alphabetical order. Now, if I want to decode a message, I can just put it in the ciphertext. I happen to use this exact same key, and it says subscribe to one Findog. HTML, we've got our header stuff, our introduction, our plain text, which gets updated on change to encode or decode. I have my middle section, which takes in the key, and so that will just be the letters in whichever order you choose to put them in. And when it changes, then we update that. We have our table that will show what the new letters are. And then we have our encode and decode. If the names are the same, then that will mean it'll toggle between the 2 or 3 or however many radio buttons you have. I happen to have 2, so it'll toggle between those 2, and you can only have one set. If it's encode, it'll set encode to true. If it's decode, it'll set encode to false. My CS, we've got the table. We have our ciphertext and plain text. We have my wrapper, the key table wrapper, the key input, and the encode and decode buttons. For the JS or JavaScript, we have a decoded and encoded alphabet. We actually don't have a shift. We have our uppercase regex, our encode, and then the default key that I have set here. Here's at the decoded alphabet, which is just a basic alphabet. We just cycle through 0 through 26. And then I take the uppercase of the key, split it by every letter, and that equals my encoded alphabet. And then I just display what that encoded alphabet is. So I grab the latest key, set decoded and encoded. We have our top and our bottom row. Set the top row and the bottom row. Wrap those in rows and show it. And then we encode or decode the plain text or the ciphertext. For the encode text, we make the plain text uppercase, grab that value, clear out the ciphertext, cycle through, and encode each letter. To encode each letter, we test to make sure that it is uppercase. Again, if it's spaces or special characters, we will just pass that through here. The encoded alphabet will just get the index of that character in the decoded alphabet. And it will get that same index from the encoded alphabet. Decode, do the same thing, but just in reverse. So we have the ciphertext, get it to uppercase, grab that value, clear out the plain text, and I decode the letter. To decode the letter, again, test to make sure it is a uppercase with that regex. And now I'm going to look for that letter in the encoded alphabet, whatever index that is. It's going to be the index I'm going to grab from the decoded alphabet. Updating the key just gets the value from our key, sets it to uppercase, puts it back in the input, and then call encode decode. Encode decode, if its encoding is set to true, then we encode the text. If it's set to false, then we decode the text. For setting encode, we just set the value and call encode decode. And for the simple substitution load, which happens on load, we just make sure that the key input value is set to uppercase, and then we display the alphabet chart.